Hi, this is Tayson. Welcome to the Data Science One podcast. So this is the sixth episode. So I'm pretty excited to talk about a new data science project podcast. So let's get started with this. First, let me share my screen. Okay, go to presentation, share. Okay, now let me make this full screen. Okay. So the today's project podcast is focused on maximizing the incentive optimization of insurance propensity model. So before I begin, let me briefly talk about myself. So I was a former business intelligence analyst and the machine learning enthusiast. And I am the founder of the Data Science One YouTube channel. And I have a corporate work experience working within a mental health hospital known as KMH at a business intelligence data warehousing department. And then also I have a research experience at Cancer Center focused on medical image processing and the cancer treatment study. So these days, I'm kicking some side machine learning projects to build my own project portfolio to become a future data scientist. So here is a brief agenda on what we will be covering today. And let's get started with the business problem. So the insurance company is interested in a client who are likely to renew their policies and to develop an incentive plan for maximizing the total net revenue from collected renewed premiums. So the major stakeholders for this project will be senior management of the company, a sales agent, and their policy holders. So the main goal of this project is to predict the propensity of renewal premium collection and creating an incentive plan for the sales agent. So the main objective is to evaluate the loyalty value of clients, basically assessing the likelihood of renewal. Now, let me talk about the dataset overview. So this dataset comes with the 11 info feature for predicting a renewal label, renewal status, and there are about 2 categorical and 9 numerical features, which contains information about the client demographics and insurance premium metrics. And the sample size of this dataset is around 79,000 rows. And then on the middle, you can see the snapshot of the client demographic measures and insurance policy measures and the cost label that we're interested in predicting. And now we have some major challenges, which include class imbalance and missing values and outliers and duplicates. Now, let me talk about the data wrangling process because this is very important for getting a cleaning data and completely transform data to build our model. So now let me talk about the data wrangling pipeline. So first of all, raw data gets loaded onto the Python as a data frame. And second, we're going to treat a missing value using a measure of center tendency known as mean, median, and mode based on the data type. Then third, we're going to execute the feature transformation to basically convert the existing feature into the different format or the meaningful format. Then finally, we're going to build our model classifier based on the different selection of the algorithm that we choose, and then evaluate the model performance. Now, let me talk about the missing value replacement in a little bit more detail. So suppose first, we see a summary table, which is basically computing the missing value percentage on each of the features. And the first thing that I want to mention here is that there are no missing value of the feature, which is actually larger than 50%. So meaning that all the features are valid to use and proceed to the next step. So we are not actually dropping any feature, we're actually keeping everything. So then we're gonna apply a feature imputation. So as you can see from the left to right, we're applying a feature imputation, basically measure of center tendency. So for numerical feature, it will be usually mean, and then categorical feature, it will actually replace a value by either a median or mode, depends on the situation. Next, it's feature engineering. Feature engineering is a part of the feature transformation process where we're converting existing numerical features into a categorical feature as a group. So on the right-hand side, you can see the sample snapshot of the code, basically defining the bin size for each types of the numerical feature. This process is called discretization. And then using this discretization, we're actually generating age group, premium amount group, and the number of premiums paid group as a result. Now, I want to talk about the high-level model workflow. So basically, the model has been developed in two stages. So stage one is focused on model training and tuning. Stage two is for model performance evaluation. So first, raw data gets loaded, and then we're executing data wrangling step, as mentioned earlier, and then data partition step gets applied. Basically, what it does, it's splitting the training set into three different buckets, which is training set, validation set, and then holdout test set. So using a training set, we're going to build our model. And then once the model gets built, we are going to use the validation set to further optimize and tune our model hyperparameters to get the best validated model. So once the model gets completely validated, we're going to use a holdout test set to basically evaluate the model performance on each of the algorithms that we choose. Next is the exploratory data analysis. So now I would like to share some of the insight that I gather from different univariate and bivariate. The first is the pie chart. So as you can see, this bigger pie chart represents the client demographic breakdown by the renewal status. So basically, 94% of clients were renewed, and then only 6% of clients did not get renewed on their policies. And then further down, I created two sub pie chart representing the by a renewal status and also by the application sourcing channel. So the major take-home message that I like to mention here is that the client proportion from the highest to lowest in the magnitude order by sourcing channel is from A, B, C, D, and E. So basically what that means is about more than 80% of clients were actually sourced from channel ABC altogether. And the last thing that I like to mention here is that for this problem, we are not going to apply any resampling technique. The reason is because this problem, the focus is on the clients who renew their policies for maximizing the total net revenue calculation. So we don't really need to care too much about the clients who didn't get to renew their policy at this moment. So second is the bar chart. So here are 4 different bar charts that are plotted by the different renewal status. So first 2 charts represent the mean income by sourcing channel and mean premium by sourcing channel. So first take-home message is that the highest mean income and premiums were from clients from channel E. Then the second is the lowest mean income and premium are the clients from channel A. So this is quite interesting because from earlier pie chart, I was showing that most of the clients were sourced from channel A. Because before I see this insight, I was actually expecting something different, completely opposite, where most of the clients were supposed to be from channel E, but in this case, it was a channel A. And then the bottom 2 bar chart represent the frequency chart by the number of clients. So first is that the number of late paid premiums were mostly from 0 to 2 times. And then the second message is that the number of premiums paid on time were usually less than 20 times for the majority of the clients demographic that makes up this data set. The third, so we are looking at three pairs of histogram by different renewal status. So first plot is first pair represent percent premium paid by cash or credit. Second is age, and application underwriting score as a third. So the first pair plot is really interesting because most of the Renew clients less likely to use cash or credit to pay their premiums. Whereas in contrast, for non-Renew population, most of them actually use cash or credit to pay their premium. This is actually completely opposite trend that's found between two different populations. And with respect to age, both distributions or for distributions showing for both Renew and non-Renew populations are very close to normal distribution. However, the non-linear age distribution is a little bit more interesting because it's actually skewed to the right, representing younger demographics than the Renew age distribution. Whereas the third one, the application underlying score, is in this case both distributions are skewed to the left, and then it's actually not that interesting because what that means is majority of the clients have their application underwriting score within a mid 90 range. So it's actually not that useful or too meaningful. So last one is the correlation metrics. So correlation metric is a tool to represent the correlation of coefficient between the features and our target label. So within a black dash box is representing the correlation coefficient against the renewal status based on each of the input feature we have. So the major thing that I'd like to highlight here is that the strongest negative correlation was found on the count of the premium late by 6 to 12 months duration. And then the strongest positive correlation was found in the age in years. Now, let's talk about the model selection and some of the interesting results we have. So, for this problem, I actually ended up testing 4 different classifiers. So first is the logistic regression. So logistic regression model is where we are using a sigmoid logit function to transform our set of input feature value and calculate the estimation as output of the probabilistic range of the label being renew or non-renew. And then the second model is decision tree. Basically, it split the data on the features, and then it repeat the splitting procedure until it continues to split until each tree node left with the same class label, either as a renew or non-renew. And then third model is random forest. It's an ensemble type of learning model, creates many decision tree, and then averaging the performance of the all tree together to make a prediction. The last one is the gradient boosting model. It's a sequential type of training model in a stepwise manner fashion. So what it does is at each state, it tries to learn the residual mistake or residual error from previous state to make a better accuracy, basically reducing the error gap as much as possible from each iteration. Now, let's talk about the feature selection. So this is the set of feature importance plot that are plotted by different models. And then the major thing that I like to highlight here is that if we actually pay our attention on the green boxes, it's actually representing the common important feature that are selected, which include count of premiums paid late by 3 to 6 months, 6 to 12 months, and more than 12 months, and then percent premium paid by cash or credit. And the other thing that I like to highlight is that the XGBoost model actually ended up picking other important features as well, which include income, underwriting score, and age. So now, let me talk about the model comparison. So as a result, this is the model comparison table, basically showing the classification evaluation metrics on each model performance. So basically, the best performing model ended up being random forest classifier with the highest accuracy of 0.94, also with the log score of 0.83. So now let me talk about the confusion matrix. So this is another type of classification evaluation tool that's commonly used to assess the model performance. So basic interpretation here is that about 94% of predictions are made on the renew clients. And then there are about 6% of misclassification errors are made on non-renew clients. So basically what this means is that we need a retention plan to win back these clients, non-renew clients at some point, which is a 6% of type 1 error called false positive. Because what this means is actually this 6% lead to the conversion of loss in net revenue over time, because the company was not able to collect the new premiums, renewal premiums from these 6% of the population. Now, let's look at the log curve and the precision recur curve. So the left one is showing the log curve that are plotted for 4 different models. And then the best model was actually random forest with the area under the curve with 0.84. So what this means is that about 84% of time, the model is good at making or separating prediction for clients and renew clients versus the non-renew clients. Whereas on the right-hand side, we're seeing a precision recur curve for the random forest classifier with the average precision of the 0.98, meaning about 98% of time, the model is actually good at predicting renew clients from the total number of actual renew clients as a result. Now, let me talk about the conclusion and some of the future work. So, as we mentioned earlier, one of the goal for this problem is we want to actually calculate the incentive optimization plan for providing incentives to the sales agent, and then also maximizing the total net revenue for the insurance company. So in order to calculate that, we're given 3 pieces of information. So first is 2 relationship curves that are plotted here. So the top one represents the incentives provided to the agent. On the y-axis represent the effort of hours put by sales agent based on their incentives. And then the second relationship is representing the effort of hours put by sales agent. And then the y-axis is representing the % improvement in renewal probability. And third, as a last piece, we're given a net revenue equation to calculate the total net revenue for the insurance company that they collected. So the last thing that I'd like to highlight here is that we have insurance propensity model variable. So I'm not going to list everything, but 3 of them are derived value from the relationship. And then we have a probability of the benchmark, which is a renewal probability calculated directly from the best model rock score value. And then we're given the premiums as a raw data. And then finally, we are calculating the total net revenue from all of the renew client population. So as a result, let's say, based on the 5,000 observation or the clients, the estimated total net revenue the company is collecting, it's worth about 3.3 billion US dollar. So for the future work, we're interested in creating a churn modeling. So what that means is we want to predict or win back those clients who didn't get to renew their policies. So in order to do that, we have to apply some resampling strategy as a downsampling or upsampling. And the last piece is having an additional feature collection. So if possible, it is better to include insurance activation period as a time series data on each of the client to represent how long they have been activated or with the insurance company, because that actually provides us a good idea on the loyalty value of the client as well. So any questions? Thank you for listening to this podcast. And it was a very interesting topic. And I would like to share more interesting project podcasts in the future as well. Thanks for listening. And then see you guys next time. Bye-bye.